We're doing a 1-minute rescue today. You're about to see the exact minimum effort tweak that delivers the absolute maximum mark impact for your Cambridge IGCSE Physics 0625 exams. We're not rereading textbooks here. We are rescuing your grade from the single most devastating trap in the entire syllabus, and we're starting right now.
Picture this. You're in the exam hall. The clock is absolutely ticking down. You see a standard area calculation, a length of 20, a width of 10. You confidently multiply 20 by 10, you write down 200, and you move on. Feels like easy marks, right? But on results day, the examiner slaps a big red 0 on it. Why? Because the length was in centimeters and the width was in millimeters. This right here is the painful everyday trap where you literally bleed marks just because of a simple unit mismatch.
Look, you simply cannot afford to lose these easy method marks. When you're tackling energy, work, power, efficiency, it's honestly rarely the math itself that takes you down. It's this exact mathematical trap, inconsistent units, that just destroys your grade boundaries. If your units don't match up before you even touch your calculator, the final answer is totally cooked. Your method marks just vanish. But hey, don't stress, because we're going to fix this whole thing in under 60 seconds.
So why does ordinary revision usually fail here? Well, you can memorize every single formula in the syllabus perfectly. Speed is distance over time, work is force times distance. But if you accidentally mix standard SI units, like meters or seconds, with their sneaky variations, like kilometers, millimeters, or hours, the whole calculation instantly breaks down. The International SI system exists so we can compare data seamlessly. You've got to standardize that data before you calculate anything.
Let's lock in a massive quick win right off the bat with these non-negotiable SI base units. You need to memorize these right now, because they have to be used consistently across all your energy, work, and power calculations. Dealing with energy, your final output is the joule, capital J. Power, it's the watt, capital W. Force is the Newton, capital N. If your starting numbers aren't aligned to standard SI base units, you are never going to hit the correct derived units. It's just a hard rule for Physics 0625.
Now you might be thinking, okay, but how do I actually spot when an examiner is deliberately trying to trick me? Well, in just a moment, I'm going to show you the exact examiner clue that changes your calculation completely. But first, you absolutely need the framework that makes that hidden clue glaringly obvious every single time you look at a paper.
Meet the ultimate high-mark framework. This is exactly how top-tier students take a really messy calculation and turn it into a totally structured examiner-proof response. Step 1, isolate the concept. What's the core physics rule? Step 2, grab the evidence or data straight from the text. Step 3, hit it with scientific reasoning. Do these data points actually match the concept's rules? And finally, Step 4, use precise examiner wording to execute your answer. Let's see this in action. All right, let's run that framework. Step 1, our concept. For area, units have to be consistent. Step 2, the evidence. We're given a length of 20 centimeters, but a width of 10 millimeters. Step 3, scientific reasoning. These units do not match. So we have to convert that 10 millimeters into 1 centimeter to force them to align. Only then do we hit Step 4 and calculate 20 centimeters times 1 centimeter, giving us a beautiful examiner-approved 20 square centimeters. With this framework, the unit trap doesn't stand a chance. Okay, you really need to look out for this next massive trap examiners love to set. Imagine you've been super careful. You made sure your distance is in meters, your time is in seconds, you plug them in. The number your calculator spits out is strictly meters per second. It is absolutely not kilometers per hour. Examiners test this constantly. They feed you meters and seconds, ask for the speed, and just sit back hoping you carelessly write down kilometers per hour just because it's what you see on road signs. Do not fall for it. The inputs always dictate the output.
And this leads us perfectly into a golden piece of vocabulary you're going to want for those heavy explain or describe command word questions. What actually is a derived unit? Well, it's just a unit based on a calculation. Take meters per second, m/s. It quite literally represents the number of meters traveled in each single second. That /, you read it as per, and it just means division. Dropping the term derived units into your written answers is a surefire way to prove to the examiner that you know exactly what you're talking about.
Right, we need to crank up the stakes here, because this next part is where even the really strong candidates lose their footing. Converting simple 1D lengths, like knowing there are 100 centimeters in a meter, is usually pretty breezy. But the second we move into 2D area and 3D volume conversions, total panic. Think about the dimensional shift. If there are 100 centimeters in a meter, why are there 10,000 square centimeters in a square meter? Simple, you square the conversion factor. 100 times 100 is 10,000. And a cubic meter? You cube it. 100 times 100 times 100 gets you a massive 1 million cubic centimeters.
Let's walk through the actual math here. To get from centimeters to meters, you divide by 100. Super easy. 500 centimeters becomes 5 meters. But if you're converting an area from square centimeters to square meters, you've got to divide by 10,000. So 5,000 square centimeters is really just 0.5 square meters. And volume? To jump from cubic centimeters to cubic meters, you are dividing by 1 million. So 50,000 cubic centimeters violently shrinks down to just 0.05 cubic meters. That conversion factor multiplies drastically when you're dealing with squared or cubed values.
All right, challenge time. Let's see if you can spot the physics error here. A student writes out this calculation. Volume equals 50,000 cubic centimeters, therefore, volume equals 500 cubic meters. I want you to actively pause this explainer right now. Use the framework we just built. Look at the evidence, apply your scientific reasoning, and figure out the fatal error. What did they do wrong, and what should the actual answer be? Take a second, figure it out.
So, how did you do? Here is the exact examiner-style correction. The flawed answer assumed that because we're going from centimeters to meters, you just divide by 100. They completely ignored that they were dealing with a 3D volume. 50,000 divided by 100 gave them 500 cubic meters, which is an impossibly massive volume that guarantees literally 0 marks. The top-band answer applied the correct process. They recognized the cubed unit, they divided that 50,000 by 1 million, and landed precisely on 0.05 cubic meters. Nailing that one-dimensional shift is exactly what rescues your final marks.
Let's quickly recap the massive wins we've just secured. You know how to standardize your SI units, you get how derived units work, and you've completely mastered those brutal 2D and 3D conversions that trip up thousands of other candidates. Your math skills are rescued, and those method marks are safely in the bag. But here's the critical, unresolved problem. Having perfectly converted units will do absolutely nothing for your grade if you misidentify the variables in a practical data investigation. Seriously, if you can't properly plot the independent and dependent variables, all this flawless math is kind of useless.
You absolutely need those practical data analysis skills to link up with your new unit mastery to guarantee full marks. To unlock that complete rescue kit, click the next explainer on your screen right now, where we are diving into the practical data coach. And make sure you subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, before you click, just ask yourself, will your newly flawless math survive a practical exam, or are you going to analyze the wrong variables entirely? Click over and I'll see you in the next explainer to find out.